Today, we're on an 11,000 acre peach and pecan orchard in southern Georgia, sitting down with Michael Pisciotta, CEO and founder of Poma AG Group, a biological consulting firm. Michael brings decades of experience in agronomy, including time as director of the Southeast for a major fertilizer retail company. My name is Jack Washburn, and today we're going to be diving into the transformation happening across the industry and what farmers and crop consultants need to understand about biologicals and how to navigate this new market. All right, Michael, where are we today?
Man, we are in a transitional peach orchard in middle Georgia right now. I say transitional because historically for the last 13, 14 years, this has been a peach planting. Standard kind of population, 144 trees per acre. But as you can kind of see, there are some larger trees. These are pecans. Depending on where you are in Georgia, you might say pecans, but these are a transition. So over the next year, a lot of these peach trees that are in commercial production right now, they'll be gone, and it will be a full-fledged pecan orchard.
Wow. So how'd we get out here? Who is Michael Pisciotta?
Well, you know, I've been really fortunate and blessed to be an agronomist for manufacturers. We were looking at different trials, different nutritional formulations, different biostimulants and biologicals, and trying to observe what the impact was on fruit quality, as well as tree physiology and dynamics. And so, you know, over the span of roughly 5 years here in middle Georgia, I was really fortunate to look at things like calcium dynamics, fruit firmness, bricks, and quality through the lens of different in-season applications and year-over-year applications.
Awesome. Yeah, I'd love to do a walk and talk, and we can
Man,
talk
let's do
about,
that, dude.
you know, your experience in nutrient management as an agronomist. So
Yeah.
you were the director of agronomy for all of the Southeast. Well,
Yeah.
how'd you come to that position, and what was being in that position like?
Well, it was good. It was a lot of phone calls, and I would like to say it was a lot more agronomy. But the truth is we were really doing a lot of in-field work.
Mm-hmm.
And so anytime that you have in-field work, or maybe new people that are coming into the industry, that they had lots of questions about what they were seeing. And it was a moment of like, don't tell me what it is, tell me what I'm looking for.
Right.
And so every day I'd have phone calls that would come in, and folks would say, hey, you know, like, how do I need to be approaching this agronomic use case? Or what do you think this product's gonna do in this kind of environment? And so kind of coaching folks through that thought process, that logic, and trying to ultimately get growers in different use cases for products that fit.
Mm-hmm.
And so that they're gonna see a ROI and they're gonna see how to benefit out of those.
So Michael, if you get a new client, you're stepping onto their orchard, what's the first thing you do? How do you set up that conversation? How do you enter into a new area?
Man, my first thing is to know as much as I can about that scenario. And usually it involves the rear view mirror, not necessarily the windshield.
Yeah.
So I want to know what they've done. You know, has there been soil amendments? You know, how are they satisfied with kind of their soil test? Do they feel like they could be getting more production? What is their goals? Maybe they have a reduced input strategy, or maybe they want to transition away from a certain input that they're using right now. And so I usually try to find out that rear view mirror scenario first, and then I say, hey, tell me about where you want to go. Tell me about what your windshield looks like and where are you driving to?
Right.
Because for me, I can help them drive and navigate that as an agronomist, but I also want to know what their perception of where they need to be at is.
So with all of your clients, you were talking about these camps that each kind of operation falls into. What are some of the patterns that determine, you know, their goals and methodologies that they want to do?
Yeah, a lot of their, you know, where they fit as far as their production, maybe their size, maybe their crop mix. You know, a lot of those kind of determine where my mental state should be as an agronomist. You know, is this something that I'm approaching with a singular year focus on?
Mm-hmm.
And how am I going to deliver those results in their expected amount of time? Sometimes, like we're on a large farm right now that's got several thousand acres. I know that they're going to want a stepped-in approach, and that they have lots of variability with where they're farming, maybe their irrigation type, maybe their current nutritional supplier. And so there's a lot of variables that I have to factor to meet them where they are. versus just saying, okay, this is my standard framework of what I'm going to do. So
Right.
I have to be a good listener,
Yeah.
and I have to find out as much as I can about those operations.
Break that piece down for me. You have, say, you have this wide spectrum. What are like two examples that you can think of in your career of where you're making completely different management decisions because the starting conditions are different and their goals are different?
I have personally seen management decisions within the first 3 years of a crop like apples make a massive production difference for the first year that those apples actually go into commercial production. And what does that look like? That looks like 3 to 4x of just commercial viability within the first the first cropping season, all based on year over year decisions that have been made from looking at, number of branches, trunk thickness, tree growth, being able to hit a wire or hit a trellis. And so you look at all these different decisions and you say, okay, I want to get to that wire as fast as possible. I want the strongest fruiting zone possible. And maybe I'm not going to maintain this program for the next 10 to 15 years. Maybe I'm just looking at this high energy, high input system, higher management, higher touch system for the first 3 years. And then after that, you know what? We're going to slowly build things down, or we have just kind of some maintenance to do. And so knowing that the grower is okay with that, gives me a lot of flexibility as an agronomist. Sometimes when you walk into a scenario, people want immediate things. They have a problem and you've been hired to solve it. So what I mean by that is they might have a water quality issue, or they might be getting to a stalled out period of growth. And that's like a plateau that they feel like they can't normally break out of. And so they've made a phone call to me or another agronomist and they said, all right, what do you think about this? Come look at this. So we'll go and approach that problem the same kind of way, but what they want is they want to fix.
Yeah.
Like they don't really have time because maybe they're harvesting sod.
Yeah.
An acre of sod around these parts, it doesn't stay an acre of sod for very long because there's a lot of construction, a lot of new home development, and they want to be able to harvest. And so they can harvest 2 or 3 times a season with the right plan, and those are dollars in their pockets. And so they want to manage to that. And if they have a problem that they're not going to be able to harvest at all, then that's something that they got to solve.
Right.
And so, we'll have to go in, really open up that lens of things we look for: irrigation, water quality, compaction, soil dynamics, history, and then that last frontier is microbiology. And I say it's the last frontier because right now it's where growers are looking last.
Yeah.
But really, in my mind, it's where they should look first.
Tell me about that. Like that seems to be the core centerpiece of what everybody's looking at and talking about right now in the entire industry.
Yeah.
So somebody that's in Southeast, you're in Georgia, you're working in these multi-thousand acre cropping systems.
Yeah.
Biology and looking at biology 10 years ago was only for the 5 acre market garden box truck growers or the people that are doing permaculture, regenerative ag, and now it's like coming into full mainstream. Kind of talk me through the past 5 years that you've seen and where you think it'll go.
Man, I don't know where it's going to go. Let me just kind of say that first. And I've been really blessed, Jack, to have opportunities to kind of be interested in this, and also have people that supported me in looking at this, and also through the lens of competitive landscape of products. People say, okay, what are your claims if you're a product agronomist? What are you trying to do?
What's that? What's a product agronomist?
Okay, so if a product agronomist would be somebody that works for a seed, a fertilizer, a biochemical company, a biological company, a biostimulant company, anywhere that you fit on the supply chain for producing an input. And so, a lot of these kind of product agronomists, they go out, they manage the stage gate process of maybe new products coming to market. Some of them are understanding product life cycle, something that's been around for 30 years.
Yeah.
Maybe it's really cutting edge, but you don't have the background around knowing what the latest and greatest feature of that is. And I say features because a lot of these features are inherent.
Yeah.
What I mean that is natural substances like humic substances, plant extracts, sea plant extracts, protein hydrolysates from animal and plant sources. A lot of these have inherent properties. And so the reason that you want to use these is for these inherent properties. And they've seen things in the field that maybe you couldn't explain.
Right.
And so now what the benefit of we have right now on the biology, you mentioned, hey, 5 years ago, a market gardener, you know, might say, oh yeah, really, I'm looking at these nitrifiers, or I'm looking at these phosphorus solubilizers, and they might have some evidence of that they might be paying a lot, you know, for their little sample to understand what they're doing. Now these things are able to be scaled, and they're able to be looked at through the lens of saying, okay, where are we going? And how do we conduct a trial where we can say, all right, I know I'm trying to impact this microbial community with my product. I need to have some data to support that. And so I say it's feature because it's inherent. These are natural materials, and using natural materials the right way is a critical element of a lot of these advances. And now we have some data of just saying, okay, where do these fit into the matrix of products that I have at my disposal? Doesn't, you know, have to win a product category. You know, everybody thinks that they have the best one. And so once I cut through that noise, really I'm going to say, okay, what is your trial data? Where is it from? What does it look like? And then why should I use this agronomically? How does it fit into a current production system that I have? Is it easy for me to use? And so there's a lot of elements to that specifically where I'm always looking at different kind of sources, maybe different inherent properties within natural materials. And I think that's where agronomy is going. Agronomy is going for these things that now that we have better data tools, now that we have better ways to assess things in the field, now that we have growers that care about this conversation, that I would call our massive growers. They're driving a lot of these conversations forward. And so, you know, really it's about seeing it on your farm. It's about, can you make it make sense of where you're headed, looking through the front, you know, the windshield versus the rear view. And so, yeah, it's really complex right now, the biological landscape. It's not getting less complex, but also our tools that we have for parsing through nuances is also getting better.
That piece I want to pull on a bit. It's you find the bottleneck and you remove the bottleneck. And so oftentimes it's how do we figure out what the bottleneck is for increasing production or increasing soil health at the same time, and then how do we remove that bottleneck? And I feel like different biological products have different bottlenecks that they remove, and knowing which ones to apply when seems like everybody's asking that question, and it's kind of difficult. What's your process on how do you assess what a bottleneck is on a specific operation and how to approach that?
A lot of times the pests and pathogens evolve much faster than our innovation in fruit and vegetable production. And so that's been a huge challenge. And I think that with our linking that back to biologicals and processes, if I understand how a biofungicide works, and I can say, okay, it's going to give me these different types of protection versus a synthetic chemistry that I might be using. Well, can I take that to a field somewhere and test that? Can I test that theory that I have to say, you know, we've had this issue here. Maybe we look at, you know, photosynthesis or ways to upregulate chlorophyll, or maybe there's some pH challenges. Maybe there's some water challenges. There's all different kind of things that we can try to say, okay, how do these systems work together and how can they work better?
It's like you're taking so many disconnected pieces and figuring out how they all come together. And I feel like historically, and you know, I'm young, so I don't really know historically, but from what I've heard is we're often looking at them as separate different systems. And so you have irrigation as one system, chemistry of nutrient management as another system, you know, plant protection with disease and pest pressure as a different system. But now we're seeing like biology kind of puts all of these systems together. And if you have increased biology in soils, you have increased nutrient uptake, you have increased pest and disease resistance, and you have increased water holding capacity for irrigation, which is awesome. And everybody sees that and they're like, wow, that's great, but you know, probably not not on my farm, on my operation, you know?
Right, yeah.
And so it's like knowing how do you take that really big idea and shrink that down into something that's actionable, where somebody doesn't feel like they're getting sold the moon and they're able to really know exactly what they're buying. Because there's a big difference between buying, 200 units of nitrogen that you're going to put down because that's your plan and that's your program, versus now we're going to put down bugs in a jug, and it's like, or we're going to put down a biostimulant or something else, and where you don't know exactly where that one-to-one input to output is. That seems to be a hurdle. Kind of walk me through how you've gotten through that process and kind of thought through that.
Yeah, I mean, I'm going to steal this idea from the way that this gentleman said it. I was listening to him the other day, but it's kind of been in my mindset a lot of this time, because we work in part and parcels of how these fields are set up. We're standing in the middle of the field, and there's drip tape running through the length of the field, and I have to account if I want to inject something within a fertigation cycle. I have to account for that. Is it going to flow with my emitters? Is it going to come out these orifices? Is it going to come out the right way? And ultimately, what am I going to do out there once I do that? And I have to have a trial set up. And so you look through the scale of saying, okay, what can I split a block in, or what can I run a fertigation cycle in, and how can I compare it to something else? I think a lot of the bad rap of sap testing, I want to speak positively about sap testing just for a second, because there are moments that it absolutely pays. Anytime that I can have time over time comparison, and then I can parse that with a comparison of another area that I'm also measuring the sample on, that I feel good about, old leaves versus new leaves. And then, somebody earlier when I was discussing this idea with them, they mentioned, you kind of throw it all out there unless you have knowledge of what that crop's about to do. And so you have to have a really good grip and handle on what's about to happen. And there's ways that you can only know that unless you're putting eyes on it.
Right.
And so sap testing has to be done with knowledge of what's about to happen, maybe where, the season's been at, where it's going to go. And that'll allow you to kind of, even look further in your GPS, if you were talking about the windshield analogy, and say, okay, I know I have a big turn coming up right here. And that sap is going to tell you that turn's about to happen.
Tell me about that. What's that turn? Is that like a large nutrient uptake at a certain time of the season, and you have to prepare for that? And
yeah. I mean, that's one option, is a large uptake curve. You look at something like potassium on watermelons. Right here, we're looking and saying, okay, we know that this feeding cycle is about to go through the roof. Tomatoes is another big calcium, potassium uptake conversation. And so we want to get ahead of that, but a lot of times things that are immobile, like phosphates in the plant, we look at those and we say, okay, that is a really good one, because it's going to get stolen from somewhere.
Right.
And it's going to be remobilized in the plant. It's got to come from somewhere. And so we want to know when that levels are draining down to sufficiency, to deficient, and we can maybe not pick that up on a tissue test, but we can pick that up on a sap test.
Right.
And so it's really hard. It's really difficult to do doing sap testing the right way. But if you can keep that, on the tracks for longer, because you'll see those symptoms come up. When I was talking to this really awesome agronomist down in Florida earlier today, he was telling me about this story of taking the sap test for strawberries, and then he was able to kind of put the brakes on a potential phosphate deficiency through the sap with perfect tissue test. And so that was a really unique way of saying, okay, I can predict this, I can prepare, I can apply for it. I might still see it. We have a lag of what we're doing out in the field and how we're responding to it. But if I can see it coming through the sap first, then I can go ahead and attack it aggressively and hopefully keep this on the tracks.
So to me, it's sounding like not only do we need to account for time of before and after in the rear view and in the windshield, but also comparing this block to another block to know exactly what's changing. So we have forward, backward, left, and right for what we're comparing, rather than, we're going to try something, so we're just going to put it down and
Right.
see, you
Yep.
know, and so being able to look at, you know, what's about to happen versus what's happening in the block to our left, you
Yep.
know, that seems to be very important. What have you noticed in trial design and that kind of idea of setting up trials for like an orchard like this,
Yeah.
that's, you know, thousands and thousands of acres.
Yeah, I think we were kind of discussing it earlier, and Jack had this idea of like, what is your best orchard versus what is your worst orchard? And I think a lot of growers think about trials in the same way. They say, okay, do I want to try to top out the performance on my best orchard, or do I take it to my worst performing orchard? And do I say, okay, we can split that and see how much more I can benefit from just one thing?
Yeah.
And you know, growers know where those blocks are, and the truth is both.
Right.
Like, you really need to see it both ways.
Right.
And the truth is even more, you know, there's probably somewhere in the middle of saying, okay, you know, when I started evaluating peaches many years ago, what I wanted to know is, can I move the needle on early season varieties? Because they command the greatest premium on the market.
That
Man,
makes sense,
first to market, first money. Hey, like, you know, people, they have different quality levels of acceptance for those first peaches too. And I say, why do we have to struggle on that quality metric? Why can't we have great size? Why can't we have great color? Why can't we have great firmness that has a longer post-harvest storage capacity? Why do we have to suffer from any of that?
Right.
But over time, Jack, what I realized was that I had actually missed the mark. That the greatest opportunity is not necessarily the earliest peaches. The greatest opportunity is the longest window for that crop to have loss potential and yield loss potential. And so my framing totally flipped. And you know, when I set up my trials at this really awesome tree fruit research university down here in the Southeast, you know, what my ask was like, hey, give me an August variety where I know that I got more spray programs, I got more pest programs, I got more bacterial spot, fungal pressure. That's going to allow me to test something greater. And so even I have that lens now on corn as well.
Yeah.
You know, a lot of folks would say, well, how do you want to try a product on a corn variety? Well, I would say, well, give me your growing degree days or your maturation date. You know, is it 118-day corn or is it 81-day corn or whatever it is? You know, give me some different kind of maturity stages. You know, we're gonna hit different planting windows that are gonna have different stressors. And then I'll be able to test a product like a Abiotic Stress biostimulant better. So Abiotic Stress, anything environmental, weather. A lot of people think like cold soils could be Abiotic Stress. A lot of people think heat during something like tasseling or pollination or fruiting is a stress. A lot of people would look for a crop like potatoes, like, you know, an unsung hero of potato yield loss, or I guess unsung villain of potato yield loss, is high nighttime temperatures.
All right.
And what that has to do is bleeding off carbohydrates in the soil because you have these unseasonably high overnight temps. And the plants are just breathing and breathing and breathing. And it's like, if I go out and run a race, the last thing I want to do is getting a scalding hot shower. Because when I get out of that shower, guess what? I'm still sweating. I'm still sweating, and I don't want to sweat. Like, I need to like let my body cool down before I actually try to like get the sweat off myself, because then I'm like at an ambient temperature. Well, there are crops, especially tuber crops. Sugar beets is in this category. Sometimes onions get in this category, even though onions grow past a lot, and we grow them early in the state of Georgia to kind of avoid these things. But last week, it was March, and it was almost touching 90 in the state of Georgia. So we still have lots of potential for those things as we're looking at finishing off a crop. So to answer your question on abiotic stress, every crop stage has a different kind of trigger, and sometimes there are multiple triggers. A lot of times you can have a specific weapon to target maybe one of those, or you can have a more generalized weapon to target a broad group of those.
So what are some of the weapons that are in your arsenal for combating abiotic stress, is particularly around the conversation we're having with different products or different approaches? So you have like cultural practices you can do, and then you have the applications of products. So you can buy something and apply something, or you can do something. Kind of walk me through for abiotic stress what your approaches
Yeah,
could be.
so on the buy something approach, I always look for, I mentioned inherent properties earlier.
Uh-huh.
You know, if I have a seaweed material that grows in a tidal range of 40 feet that are different, you know, think about this. You know, we're standing right here in the middle of an orchard that has pecan trees on it, pecans, excuse me. And pecan, you know, this tree is, you know, it's probably 30 feet right now. Well, there's tidal ranges around the world in Canada and France that those tidal ranges are higher than this pecan tree that we're standing underneath.
Yeah.
And so if I'm a plant growing somewhere in the difference of the height between me and you, and I have to endure the salinity of the ocean, I have to endure all these things, I probably have some pretty awesome stuff inside of me to make myself be able to withstand that.
Interesting.
And
so are those, do you think those are microbes? You think those are, you know, extracts? Like what's the difference between those kind of breakdown when it gets so small that we can't see it with our eyes, and now we're going based on trust that that's the case? Kind of what's the science that you've seen behind how that works?
So a lot of times on something like a seaweed extract, you would look for biochemical or bioactive properties. And a lot of these shine through different phytochemicals. Some people would call them a general antioxidant. Some of these have different molecular structures, different phenolic compositions, different carbon compositions, but most of them would be from the vegetative part of that plant. And they would be extracted that way. Right. And so if it's a part of the plant that's getting highly exposed to these extremes, that's where you're going to source from that. And so there are some really interesting extraction methodologies around plants. People see these in tropical plants as well. You know, things like cactus, obviously they grow out in the middle of the desert. They have a high capacity to that. But furthermore, what I would say is you ask about, well, what about biology? Well,
how does those extracts, how do they interact with the plant, and how do they help like the crops we're growing? If they're helping that plant itself, how does that transfer?
Yeah, well, so that's a great question because a lot of the folks that are in that kind of camp of manufacturing, or maybe they have a proprietary material, now they're starting to look at this more as a system.
Right.
And when I say that, it's because there is interplay between soil microbes and really high capacity things like seaweeds, even though we have a whole different set of things in the ocean, obviously, that contribute to, you know, oceanic plant growth. People are starting to be really curious. What is the soil microbiome of the ocean floor?
Interesting.
What is that?
Yeah.
What are we tapped into there? That how does it work? Like these systems are, you know, we're getting into a technology age right now where we're going to learn more in the next 5 years than we knew in the past 500 years.
That's so exciting.
So are we ready for that? And are our input systems ready for that? Are we going to be able to catch up? And so I look at certain things too, like protein hydrolysate, and I look at things like, you know, maybe extremophile bacteria. I mentioned the cactus because, you know, there's plants that grow out in these extreme environments. But what adapts those plants? Is it their genetics? I mean, some of these plants, Jack, they're 100 and 200 and 300 years old. They're ancient plants. So why, if they're not genetically breeding with other plants, how can they keep going for so long? And what we're finding out is it's the soil microbiome that taps into that. You know, there's been some really awesome, you know, in a totally different way, there's been a lot of nutritional deficiencies now that people are actually looking at the soil microbiome first.
Right.
And I say that specifically because in golf courses and high-end turf grass management, people have always said, oh, we have take all or brown patch, or we have all these things. It's a manganese problem. We have manganese problems. But now a lot of these researchers at awesome land-grant universities have looked the layer deeper and said, actually, it's not manganese. It's the microbes that process manganese for the plants. That's where the hitch is. And so we're starting to see evidence of this play out in different ways. You know, the biological conversation is going extreme. I cannot wait to see where it's going to go in the next 5 years. But I will say, you know, harnessing nature is really what we're after.
Right.
I use the framework of inherent properties because, you know, you might be born 7 feet tall.
Yeah.
you might be born 4 feet tall. Well, it's obviously, what your genetics is, and, what God gives you is what God gives you, but how do you use those talents the best for, especially something like if I'm going to go out and run,
Right.
I'm going to run a race and do something, and this is a marathon. Growing peaches in the state of Georgia, it's a marathon, and these peach trees are coming to the end of their race. And so what are we going to do between now and the end to get the most production out of them in this timeline?
Yes, in
But
this specific context of,
Yeah. And so there's just a lot of excitement around things that maybe I finish a crop, maybe I start a crop, maybe I help it somewhere along the way. These plants are, they're not grown in a greenhouse. They're outside. They're going to have stress.